Welcome to the CompTIA A+ 220-1101 or Core 1 exam. This is Objective 2.7, Internet Connection Types. Today we have so many ways to connect to the Internet. In this video we'll look at different Internet connection types. One increasingly common form of Internet connectivity is through satellite networking. This is where you would use a satellite dish to communicate with the satellite that's in low Earth orbit. We sometimes refer to this as non-terrestrial communication method because we're communicating to a device that's in space. As you can imagine, having a rocket take your satellite connection to space is a relatively expensive task. So the cost of having satellite connectivity can be more expensive than something that might be terrestrial. The speeds over these satellite links can vary widely, but it's not uncommon to find 50 megabits of speed down and 3 megabits of speed going up. As you can imagine, it's a bit complicated than simply connecting a cable in your home, which means that you would probably use a satellite connection where no other type of internet connectivity was available. One of the challenges with this communication is that satellites in space take more time to get the packets back down to Earth. This means that you might have to deal with latency that could be going up to 200 or more milliseconds. There are newer satellite technologies such as Starlink, which advertises 40 milliseconds of latency, and they're working on getting that down to 20. These satellite connections tend to operate in higher frequencies such as 2 gigahertz, and they operate over line of sight, which means if you do not have rain or clouds that come in, you'll have rain that fades away and you'll lose connection between the rain and your satellite. One of the higher speed on the terrestrial types of networks is fiber. These fiber optic links are great for internet connections because you can send a very large amount of information in a very short period of time. Of course, fiber optic tends to be a bit more expensive because of the equipment and the costs for fiber optic connections. You would have more expensive repairs for the fiber optics themselves and for the equipment. But it does allow your communication over very long distances. If you've worked at all with enterprise networks, then you're very familiar with fiber optics, connecting your infrastructure devices and the cores of your networks together using fiber optic technology. We've taken the concept of running fiber optics in a network core and extended it to running fiber optics to your home or to your business. This greatly improves bandwidth for internet connections and gives you other options for sending or receiving information. If your home or business is serviced by a cable company, then you might have the option for cable broadband. This brings an internet connection into your home or business using the same cable that you would use for cable television. Broadband describes a method of communication where you can send multiple streams of data across a single wire by communicating across multiple frequencies on that wire. This means on a single wire you can transmit video, voice, data, and use different frequencies on the same medium. If your home or your business is serviced by a cable company, they might be able to provide you with cable broadband. This brings in different kinds of communication and even television. The standard of sending this data over the cable is called DOCSIS. That stands for Data over Cable Service Interface Specification. This DOCSIS standard supports very high speeds, and it's not unusual to find DOCSIS networks that are 1 gigabit or even higher. This also means you don't have to bring additional cables or services into your home. You can simply use what's available for cable television and hook it up. Another technology where we're sharing some existing copper that we may have already in our home is DSL. DSL stands for Digital Subscriber Line, although in most cases it is ADSL or Asymmetric Digital Subscriber Line. DSL uses the existing telephone lines in your home to be able to provide you with high-speed network connections. We call this connection asymmetric because the speed of the download is often faster than the speed of the upload. It is not uncommon on DSL networks to have a downstream speed of around 200 megabits per second, but the upstream speed is limited to about 20 megabits per second. These speeds are also limited by how far away you are from the central office or CO. If your CO is an extended distance away, then those speeds tend to decrease. There is about a 10,000 foot limitation. Many of us use cellular networks for internet connectivity, especially if we're away from our office or our home. These use the mobile networks that you would commonly associate with a cell phone. But instead of sending voice over that network, we're communicating, sending data. One way to provide this connection is through tethering, where we would physically connect to our phone via USB or through Bluetooth and use our phone then as the internet connection. Many phones also support this ability to become a hotspot. So you can enable 802.11 capabilities and anything in range to use that 802.11 network through your phone to access the internet. And in some areas, you might have an ISP that is able to send information over a wireless network to your home. That would be a WISP, or a wireless internet service provider. Unlike a satellite internet connection, we're not sending information to and from space. Instead, we're sending information to a local ground station very close in our geographic area for that ISP. Usually you would find a WISP operating in rural areas or places where there's not a large infrastructure already available to send internet traffic. Some of these wireless ISPs will use meshed 802.11 to be able to connect devices. They might have a 5G connection for your home internet, or they might be using some other type of proprietary wireless connection. In many cases, you'll need to extend outdoor antennas and be able to send and receive information from this WISP. And usually you get a pretty good performance from these wireless networks. In some areas, they can operate up to 100 megabits per second. Okay, we're at the end of Objective 2.7. Here's a pretty common question about networks and latency. Which connection has the most latency? So we have A, 5G, B, DSL, C, fiber, or D, satellite. Although there are different kinds of speeds that we get with these connections, sending data to and from space has a lot of latency, up to 200 milliseconds of latency. So satellite would be the worst choice. Thanks for watching.